Welcome back, guys. So this is question 2.103 of the third edition of our book, and here we are asked that three types of packets arrive at a router. Okay, so we have a router, and to this router we have three type of packets which arrive. Okay, so 10% of packets are expedited forwarding. Okay, 30% are assured forwarding, and 60% are best effort, okay, which are represented by BE. So according to this information, what do I have to find out? There are different parts of it, so I have to find out the answer of part A, part B, part C. So before proceeding to find the answers of each part, let me first write down the data which we have. So expedited forwarding is 10%. 10% of the packets are expedited forwarding. Similarly, assured forwarding is 30%, that is AF. Okay, so here we have this 30%, and BE or best forwarding or best effort is 60%. Okay, so according to this data, we can also find out the probabilities of each of them, and the probability of EF is how much? That is 0.1. Okay, similarly the probability of AF is 0.3, and the probability of BE is how much? That is 0.6. Okay, similarly on the basis of this data as well, what we can also find out, we can find out the probability that no expedited forwarding is 1 minus 0.1, so that would be 0.9. okay, probability of no assured forwarding NAF is 1 minus 0.3, so it would be 0.7, and probability of no best effort, that would be 1 minus 0.6, so that would be 0.4. Okay, so now we have this given data, and on the basis of this given data, what we have to find out, let us talk about the part A of this question. And here we have to find the probability that k of n packets are not expedited forwarding. Okay, so we have n number of packets, total number of packets are n, and out of these n packets, k should not be expedited forwarding. So it is clearly the binomial probability law. Okay, and we can very easily find out the probability that k out of n packets are not expedited forwarded, because here we also have no expedited forwarding, we have expedited forwarding, we have all the probabilities, and on the basis of it we can find out what the probability of the k out of n are no expedited forwarding. So it would be what? It would be total n from n out of k are not expedited forwarding, and the probability of NEF, whether the power is k, and the 1 minus probability of NEF, okay, and the power of it will be n minus k. Let me put their values here, and here it will be n choose k, and the probability of NEF, or here it is given also, so here it would be 0.9 k, and 1 minus 0.9 k is 0.1, and it would be n minus k. Okay, so this is the probability of k out of n are not expedited forwarding. Okay, so this is the answer of our question, part A. Okay, so this is the answer of part A of our question. Similarly, in part B, suppose that packets arrive one at a time. Okay, each packet is arriving one at a time, so we have to find the probability that k packets are received before an expedited forwarding packet arrives. Okay, so before the arrival of the expedited forwarding, we have received how many packets? K packets are received, and after these K packets we have received this expedited forwarding. We also have the probability of the expedited forwarding here as well, and no expedited forwarding here as well. So let me solve it, and for it let me move down somehow. Okay, so part B here, the probability of K packets reception before EF received. So this is what? This is clearly the problem of the geometric probability law. This is the geometric probability law, where the success is the reception of this EF packet. Okay, so until and unless this EF is not received, this can be written as the probability of what? So here probability of no EF, and it should be K, because after K packets, what will we receive? We will receive this expedited forwarding. Okay, so this will be here. So now let me put their values here, and after putting their values, what I will get? I will get 0.9 K multiplied by 0.1. Okay, so this is what? This is the answer of this question as well. Okay, so this is the answer of part B. Similarly, now part C here, find the probability that out of 20 packets, 4 are EF packets, 6 are AF packets, and 10 are BE packets. Okay, so out of 20 packets, so let me write the data here. Okay, so let me write this data here. So total number of packets are 20. Okay, so from these, out of these packets, the number of expedited forwarding are how much? Let me see them. These are, you can see that these are how much? These are 4, expedited are 4, AF are 6, and 10 are BE. Okay, so these are here 4, number of AF are 6, and number of BE are 10. Okay, so on the basis of this data, what we can find out here, we can also find out the probability of expedited forwarding, and that would be 4 divided by 20, and here it would be 1 over 5 or 0.2. Similarly, the probability of AF is 6 divided by 20, or this would be 3 divided by 10 or 0.3, and here the probability of BE would be 10 divided by 20 or 0.5. These are different probabilities. Okay, so we have found them out, and clearly this is the question of what? This is the question of multinomial probability. Okay, so this is the question of multinomial probability, and according to the given data, we have to find out the probability of 4 EF, okay, 6 AF and 10 BE out of 20. Okay. So, here according to the multinomial probability law, I have to take the factorial of the total number of the packets and divide it by the number of packets of the first class multiplied by the number of packets, factorial of the number of packets of second class multiplied by this last class, and I have to multiply them with the probabilities of each class. So, the probability of EF is given here, that is 0.2, and with it the power of it will be the number of elements in that class. Okay, this is now this 4 and also here this 4, let me write them here, this is 4 and this is here as well 4. Okay. Similarly, now the probability of the elements here, this would be 0.3, that is AF, and the number of elements here are 6, and also the probability of B is 0.5. So, writing it here, and the power it has is 10, which is also given here. Okay. So, after finding out all the combinations and all the things here, we will get the answer. So, the answer of it will be calculated by using the calculator. So, if you have found out this expression, it is also enough, and we can conclude that you have reached to the solution of this problem. Okay. So, that is it for today, in which we have discussed the probability scenario of the packets which are arriving towards or to the input of any router port. Okay. So, that is it for today, in which we have discussed a very simplified scenario in a very interesting manner, and I will talk more about the same kind of problems in our upcoming video. Till then, take care of yourself, and I will see you soon.